Hi everyone, welcome back to D4 Data Channel podcast on the topic Explainable AI in the legal domain. And with me we have Miss Milda Norkute, and she's from Switzerland, and she is actually working in Thomson Reuters Lab as a lead designer. And she is actually closely working with data scientists and machine learning experts to kind of come up with how well we can actually explain the AI component in any business solution. Actually, so it's an interesting piece of work, and today on this session, like, we'll be covering a lot of topics on explainability and how we are kind of implementing an explainable AI mechanism in a legal domain. So welcome Milda.
Thank you. Thank you for having me.
Great. So explainable AI is kind of like a big topic nowadays, and like, moreover, like, it is like a very tricky part as well, like how to explain the AI in a very layman term, or whatever it is basically. So how do you foresee, and what is the current business value, or like what is the business requirement for this particular explainability?
Yeah, so in terms of explainable AI and explainability, it has become like a important topic, I would say, more or less since 2016, which was when the GDPR came out. And it kind of like talked about, the need for the AI systems that the companies build to be explainable. And what that did, it like prompted this kind of like a surge of research into explainability, because like before that, I think like there were kind of certain one-off efforts, like people thought that was interesting. But when the GDPR came out, it suggested that it could become like perhaps more of a requirement in the long term, and that perhaps even more kind of stricter regulations could follow in due course. So I would say that was like around when like most companies as well as researchers started to take this topic seriously. And in terms of it being like a requirement, like, I mean, I think we cannot say yet that it is like a strict requirement. Actually, there are now domains where there can be like stricter requirements or policies around that. I think they're just like starting to emerge. That is not yet the case within the areas that like Thomson Reuters builds their products at the moment. But I think it is kind of good to stay, ahead of the curve. And ultimately the reason for kind of caring about, explainable AI and sort of like having that potentially as a business requirement and putting like the effort into that is so that, yeah, like you can stay ahead of the curve, but you can also start thinking about, what sort of practices you need to have, and start to sort of like lay out those processes. And ultimately we will get into more of that later, I think. But research does show that explainable AI can be good, for consumers and users. And so that is like another reason why I think it's worth investing, even if it's not like a hard-on requirement right now.
Great. Yeah. So coming on to, like, so when you said, like, okay, like, we are going to explain the AI to few people, like, so like I can see like AI system builder, end user, and regulatory body. So like, what are the pain points, or what are the crucial elements when it's kind of designing and explaining AI to each of these blocks?
Yeah, so I think the key thing is that, and like, so what can work well for like one user group as an explanation, like might not that work that well for the other user group. And so, like for example, a data scientist, the AI system builder, perhaps needs, like certain techniques to understand, like why the model is performing in a certain way so that they can perhaps debug it or improve it. Whereas from the end user's perspective, like what they want to know is like to what extent they can rely on the model, for example, in a like on a like how reliable is a given suggestion, right? Like how much should they trust it? Can they just go ahead with it? And so what that sort of can result in is that, for example, yeah, like the same visualization or a mathematical kind of perhaps display of some data like might not make a lot of sense to the end user, or might even be like too much for him or her. So there's like a need to really customize and perhaps sometimes use an entirely different explainability method for a different user group. And this is, yeah, like, I mean, within users, you could have like also like different users, even within end users, depending on how many, different types of roles or people could be interacting, with end model outputs. So yeah, that's just basically what makes it complicated. And the other thing is that there are some studies, I think, that talk about how like people can just have like different prior knowledge about AI. And so like before you decide which explanation you can go with, you also need to know, for example, what is like the level of AI literacy within your user group, how much prior knowledge do they have, like things like that. So it's just like kind of a lot of variables to think about.
Understood, understood. And then one more thing in this particular topic actually. So when like I would say like maybe like in a business perspective, I think like the end user or the kind of whoever are the actually the party responsible party for that particular product are more concentrated on like, okay, what is the business understanding behind each of these models actually. So and to define something like that, it is very difficult because we are literally converting the train models into something which should be able to understand in a very layman terms or in terms of a business. So in that front, like how complex is it to kind of design, and what are the approaches actually normally used to actually design something like that?
So, I mean, this is like something that I would say like user like centered design has like kind of tried to do for a lot of different technology solutions, like for kind of a long time. And that is the reason actually Thomson Reuters Labs have a design team, right? So it's not just like it doesn't just consist of data scientists and engineers. And so the data scientists, for example, would work with the user researchers or the designers to do exactly that, to understand, for example, the end user group as well as they can, who would be, for example, interacting with the model, right? Like, for example, seeing its outputs, or having to make a decision based on the model suggestions. And then, like, we work together to work out, for example, what's the best way to display those model outputs, also based on the user needs, to customize, for example, whether the models need to be optimized for precision or recall. And within that also falls sort of like trying to understand how much need there is for explainability, and then trying to sort of work out through, what are the different strategies that we could use for that. Like, what is, because on one hand you have like the user need, right? And what could be helpful for them, but on the other hand you have like the technical constraints, right? Like, for example, can we even do that? Like, for example, does this model even come with confidence scores, right? If that's, for example, what the user would like to see, because not all models have that, right? And so actually, and for example, and because of that, like maybe if there is like a really great need for transparency, right? Because it's like a sensitive context, right? Then maybe like actually you can decide to use like a really complex, I don't know, let's say deep neural net model, and it's better to go for something more simple, even if it doesn't perform as well as a model, because that ultimately is what, for example, would help like the user more efficient, also help the user trust the model better, and also potentially have less of a negative, let's say, downstream implications. If, for example, the model is making decisions that can be sensitive. Like, I think a famous example is whether to give someone a loan or not. Although of course we don't have those type of products at Thomson Reuters. So yeah.
Great, great. It's interesting actually from that perspective. So when you detail actually in this particular slide, like the two types of explanations, like specific and agnostic. So I'm very curious on like how you are actually defining like derived directly from the model. So in that perspective, so I feel like it is very difficult to build something like that, because okay, it can happen in like many ways. So one way is like either the model completed the prediction, and from the output we can actually build something, or is it like while training itself, the design team is kind of considering what can be shown in the as an explainable piece basically.
Yeah, so we typically would have conversations with the data scientists, as well as, of course, the data scientists would have some ideas like themselves, because we would like share what we learn about the users. Like often they would even sit in the in the interviews, or sometimes what we do, for example, we create like mock-ups where we show the users what, like, for example, the interface would look like with the model, and then they like usually they give some feedback, and likewise with the different explanation strategies. Let's say like we discussed something with the data scientists, and for example, like there was one time when we used I think it was like the decision tree, or random forest, like one of those models. And for example, the data scientists like told me that he could potentially calibrate like some kind of like scores to sort of like display how the model was sort of like that would kind of approximate the certainty of how certain the model was, that for example it was A but not B, and sort of like a spread of like kind of like a probability for that. And so then we would like yeah then we would we also visualize that in a mock-up, and we display that to the user, and we got their feedback, and they really liked that idea. So that is what we ended up going with, instead of, for example, just saying that, oh, model thinks that this case is type A. Instead, like, we showed the kind of like entire, like, because there are also cases, for example, when like the model thought that it could be A as much as B, right? And then the user knows that, okay, in this case, I should like check myself probably, because this was also like a high stakes situation where it does matter if you make a mistake. And yeah, and so like that was the solution that made sense to them. And I think yeah, I mean, because it wasn't like an additional model that had to really be run on top of that, to be able to provide that data to the user. I think that could be like an example of a model specific explanation. But like, I wouldn't say that it necessarily made, the model training that much harder. Like, I do know that there were like some caveats that the data scientists had to address, but like, I don't think they were very major. So that would be, yeah. And this is like those model specific explanations. They are usually, assumed that those can be done for those simpler models, right? That are like not, deep neural nets and things like that.
Great, great. So yeah, so when you say that data element, actually, like normally is it numeric data which we are actually showcasing, or like the textual or image kind of data?
So it can be either, to be honest. So in this case, this was like you had to choose like the different between the different types, and then we ended up like using the numeric data as yeah, like as a kind of like the explainability bit. Some users in some contexts actually, and this is again, like, this is why it's so important to understand what sort of works better for your users, would prefer if, for example, the data scientists with them would create like a buckets for them, such as, for example, model confidence high, medium, low, so that they don't have to like decide themselves like what the score means, for example. Um, and in terms of textual data, so this is like so for example, we had a so but this is like kind of like a maybe in a way an outlier, because it was a like a pointer generator network that we use for summarization. So it's not a simple model, but we ended up using, for example, attention scores from that model to highlight the text in an attempt to show what the user, sorry, to show the user what the model was like looking at. So yeah, I mean, depending on what kind of model you have, what is its architecture, like there are things that you can use, I think, from within the model, potentially as an explanation. It's just a question of how well does it work and if it suits the use case.
Okay, so if attention scores are actually projected in that way, I think like it's actually going too much detail actually, which it's really like I can't even believe that actually, because it's like a very tough thing. Like okay, so the data scientist will be actually giving the entire crux of the model, and they'll be actually building it around the particular one. Actually, I think so. So yeah, that's actually incredible in that front actually. So yeah, it's a really good work. And coming on to the other models, like so yeah, you mentioned about pointer generator networks actually. So like I believe like it will be the same like when it's considered to the other transform models actually. So or like any of these kind of models, I think like if the model explanation is actually intact with what the user needs, I think like the design is actually tuned in that perspective. So yeah, so one last question in this particular slide. So uh yeah, so how do you feel like so many of these models are actually literally black box.
Yeah.
Okay, like even in the architecture itself, some of these things we are actually not utilizing it, like whenever we are fine tuning any model or something like that. So on that front, like what are the action items actually chosen by the design team?
So, I mean, the thing is, like, there are, so this is where, like, the community believes, like, the research community believes, I think, that some of the post hoc explanations can come in. So, for example, like, Lime is a popular example where, you can, that's like a lever, almost like a model that you run on top, and then it can show you, for example, like which, like, try to predict back kind of like which, for example, words influence the decision the most, and what is like the almost like the score between the different classes. And that is like sometimes something what some people choose to run on top. But of course, these agnostic additional models only, like, you have to match them to the, like, to the model that you're using, right? So for example, like Climb doesn't work with like just any model. So that is like how research community believes that, for example, this problem can be partially addressed. And to your question on like what the design team can do, like, actually, to be honest with you, like, I think not very much, because it's one thing to keep in mind about, like, user research and human computer interaction, like as a discipline. It tends to be, and I mean, for a good reason, right? This is about human computer interaction, human technology interaction is a little bit reactive. So, the technology comes out, then we start studying like the user behavior, for example. Oh, there's a greater need for trust. Okay, how can we achieve that? And we study that, like, for example, within different contexts. But I mean, I don't think that is necessarily true for all human computer interaction researchers. But anyway, it's usually not focused on, kind of creating the technology, right? And so, in terms of like what the design team can do, I mean, it just really can guide data scientists through the process of choosing the models and explainability solutions by helping them better to understand the users, and also, okay, like, how do we study usability of those models and things like that. But actually, ultimately, it goes back to the data science and the research scientists community, right? Because if all we're doing, and I think this is right now like the tendency for a lot of the models, if all we're doing when we're creating, like, let's say, a new, like, better model, if we're just focusing on, for example, on lowering the need for training data, or if we're just focusing on, I don't know, like, for example, improving like the RU scores for summarization, and then we're just like, okay, well, we did it, we're done. And then somebody else, like, obviously wants to apply that model in a real life context with their users. And then there's this need for explainability. I mean, like, okay, so is it then on them to study that architecture and figure out like what could be used? And this is why, I mean, for example, I mean, so that was actually exactly the case with this pointer generator work network that we use for, the summarization, right? Like, I mean, I think like there were like other like we have seen that the attention scores kind of can be extracted and then they can like be visualized. So like based on the conversations that we had with the users, we realized that it could be something that could also be useful for them, right? And we sort of then did that and used it. But I mean, it has to be like possible in the first place, right? And or if not, then somebody else has to come and do this additional work on top and test it with the users. And so because of that, I think that when we are creating these better, more improved models, maybe we shouldn't just focus on okay, does it perform better on X metric. We should also think about, okay, like if this was to be applied in a real life context, and if for example, like what is there, like is there anything in this model that can be used for explainability purposes? I think it has to start at the top, and not like as a like an afterthought, because I think that would make things much easier.
True, true. I agree actually. So yeah. So before moving on, like one more point actually. So like you mentioned some of the low code platforms like Lime and everything. So like are these tools really useful in terms of explaining the stuff?
I mean, like for us so far, like I mean, like we have tried to use Lime, I think, in a couple of projects, and it just didn't resonate well with the users in those contexts. That is not to say that it can never like be useful, or it's not useful in any context, but at least like where I have tried to use it so far, like I didn't yeah, I didn't see like a big value add. And that is like the yeah, and that is the other reason, and to be honest, why I'm kind of like, I mean, it's good to have these model agnostic explanations as options. Like, I guess it's better than nothing, and you can decide which features from them you use, to explain the model decisions to users. Maybe like discover some of them are useful, but I mean, it would be just good to have like more options, right? And especially these model kind of specific things that could be used, because then ultimately that allows you, yeah, just to have more options in terms of what you can use. Because one thing that we also learned about like explainability features is that they tend to add much more value if they can have like a standalone value to the users. And for example, what I mean by that is that, for example, in the case of the summarization, so like the attention scores not only gave our users a sense that the model looked at an entire document, right, which like gave them this like feeling of trust, and then it took them to the areas where the summary kind of really came for, because obviously the attention scores were higher, and so the highlights were darker, where like the model paid more attention to. But for example, they also used the highlights that came from the attention scores to enrich the summaries that the model created, and that was like useful, like an additional useful thing, like almost like a standalone. Or apparently, in some cases, like they said that it even helped them to correct the summary, right? And I mean, and that is great, right? As opposed to like when you just have the explanation that says like, well, it's just because the data is this way, you're likely to see this stuff. I mean, it's better than nothing, of course, and it gives you maybe a sense of understanding how the model operates and what to expect, and it is important, but it doesn't kind of give you an additional value on top of that.
Understood. Understood. Yeah. So yeah, so the last point actually, like yeah, so in most of the cases, like we just skip the explainability part actually, like when it comes to production and like other tedious like in the middle of that production cycle, like we actually miss out that explainability. But right now people realize the importance of explainability, and when you explain most of these topics, like I'm pretty sure like most of the data science practitioners, it's actually a pretty good thing to understand, because like while developing itself they will start to understand, okay, there is some responsibility for us to kind of deliver or to kind of unreveal some hidden items which we are actually at any point we are not actually revealing. So that's something very interesting to understand. And like you have mentioned couple of other uh, business proportions also, like in terms of increase in efficiency. So like could you detail on like what are the observations which you have found on that?
Yeah, so this is actually from the same study that I was like talking about already. So we already touched upon the standalone value add in terms of adding additional details to the AI output or correcting it, but we did also see like an increased trust in the model outputs. And more importantly, I think what was really interesting for business was that all of that, all in all, led to 40% editorial efficiency. So basically, the users were 40% faster when they worked with explainability features than when they just had the model suggestion available. Um, yeah, I mean, if it can like, and also, I think the kind of the system. I mean, we call it the system, but I mean, of course, it was primarily the model with explainability or the model without explainability, but also the system scored like much better on all of the usability scores when it did have explainability features. So it's just kind of honestly just a lot of data from different points and different angles that would suggest that like making the effort to make the AI systems explainable or adding explainability features to AI system can like have real business value in terms of like positive impact on whoever is interacting with the model. But also, if we can make our editors faster, we can help our business to kind of cover more law cases, summarize more legal documents. Basically, it also means that we can just do more as a company.
Great, great. Yeah. So thanks a lot, Milda, for this wonderful information on explainability, and like most of these things were pretty new for me. And next time onwards, I'll make sure, at least in my development, like okay, I'll kind of try to unreveal some of these things which often we miss out actually. And yeah, like as I said, like it would be a new thing for many of the data science practitioners. And yeah, like and one more thing, one interesting part which I really like is that how good your team is actually working in a combined way, like the designers as well as the UX researchers as well as the data science practitioners, all working together to kind of bring up this explainability or delivering a solution in a much more efficient way, rather than just giving off an output. You are actually giving that entire piece or how the output is also coming. So that is often a very big thing, because ideally in normal scenario we just give the output, okay, here's the output coming from this model ABC. But what exactly is happening behind the back we are not explaining. And you have made it very clear actually, like the steps which you have actually focusing and trying to make it better. So thanks a lot, Milda, for this wonderful session. I hope all of the viewers will be actually enjoying this thing, and all the very best for the future works, Milda.
Thank you, thank you for having me, and same to you.